So good afternoon everyone. We are here to give our paper review 2 on crop yield prediction using CNN. Our guide is Mrs. Shilpa ma'am, Department of AML, and our people coordinator Shilpa ma'am and Akshatha. So my teammates are Akshatha, Jayadeva M R, myself, Nitin and Rahul Arti. So these are the contents we are going to present today. Let's move on with the problem statement. That is the problem definition. So we all know that agriculture is the basic and key concept, and it holds the most economy of our nation. So agriculture depends on different factors like rainfall, temperature, soil, type of soil, nutrients, etc. Some farmers till they use some traditional methods to grow their crops and all. So our model, our aim is to give them a CNN modeled user-friendly website so that they can predict the yield and they can even get some suggestions also how to get some more yield and all. So next we go for objectives. So in this we will train our CNN ML model. We train a ML model with the use of CNN, which will help in prediction of crops, like crop yield for a percentage of acre or an area of land. How much crop can be grown? That will be predict. Then we have 4 different things here: the front end, back end, and real-time integration and visualization. So in the back end, we will train our model using CNN model. We will take some inputs, live inputs, and we will use some free inputs and all. From the front end, we will make a user-friendly API or a user interface, which will be useful for handling for even the most least educated farmer also. Then in real-time integration, here the real-time integration refers to live data sets like humidity, temperature, rainfall, and nutrients in the soil, etc. Then visualization is like displaying the prediction of crop yield results. So next part will be continued by Ashish.
This is what the end user of the farmer interprets. It is very Now let's move on to the system design. First we have the user interface. This is what the farmer or the end user interacts with. It is made up of HTML, CSS and JavaScript. Next we have the application and backend services. Here data ingestion or the API gateway is used to input real-time or historical data. Now we have a CNN model for the prediction and data processing and ML service. Here this is the next part where the processing takes place. And last we have the business logic for recommendation engine. So next we have the data set. Here this is where all the data, user data and input data are stored. Next let's move on to the implementation details. So the technologies and tools here are listed. Front-end there is HTML, CSS and JavaScript. Next we move on to back-end, which is done in Python. ML libraries use are pandas, numpy and scikit-learn. Next we have the database is stored in MySQL. And lastly we have API keys, which we have used the weather API keys for taking the real-time inputs. And next modules implements. Module implemented data collected is collected and pre-processed. That data is trained using linear regression. It is predicted and it also is visualized output and using the tabs also. And last we have weather data. We take the inputs of data using open UDAP. And lastly we store as a vegetable. That we store MySQL and the retrieval pattern is necessary. Implemented linear regression. Here it is simple modeling. Here it is simple and it's easy to train. Next part will be based on architecture.
I'm going to explain about challenges and solutions. In this, we have encountered challenges like handling listening data and inconsistent data. Like we take real-time data set right from soil, gravity sensors, and by mobile applications. And in that, will be like some applications will be like correctly structured and will be like some missing and noisy data. And where we are integrated like the live weather API keys for predicting soil, like what soil based on the soil activity we are implementing how much water should be added to the soil. And next is like maintaining accuracy across multiple crops. One region will be like farmers will not plant only one crop at a time. They use like different seasonal wise they will plant like different crops. Type of challenges we have implemented here. Other solutions we are like we implemented data manipulation and normalization techniques for handling missing data, and we have like robotic API handling for API calls. When we call it sometime for API calling error happens. So we use like robotic error handling during API calls, and next is like for optimized model parameters for getting accuracy and performance. Next is like in future ones. Future ones will future will develop crop business detection using phone vision. If you click the photos and upload to our model, it will tell like what type of disease the plant has got. And next we will more we will deploy the system on AWS cloud storm for more accessibility and scalability for long, like it can reach every farmer. Next is like we use like multiple languages. So some farmers will know like Kannada, Hindi. That way we use like we can implement like multiple languages. Next is like existing real world testing and validation. Real world like using IoT sensors, real testing. Using nitrogen, phosphorus, potassium, data, and we'll prepare a documentation and user guide for the farmers which they can know how to use our apps, how to upload images, how to get profit based on the prediction. Next week, explain my friends.
Thank you, Nitin. It was more informative. Let's come to learning outcomes. Let's see what we learned while deploying this project. Acquired hands-on experience in implementing and training machine learning models. We learned how to train the model and how to implement in the real-time data set, and we get the output from the model. Okay, next, enhanced understanding of linear regression and its application in predictive analysis. We learned how we predict the analysis, including linear regression here. Gained experience in Flask, MySQL integration and backend development. We integrated our model with Flask and MySQL in the backend, and we learned it here. Improved teamwork, collaboration, and vision control skills using GitHub. We learned how to control our system using GitHub, and also we learned teamwork, collaboration, and all here. Conclusion: the project successfully achieved its phase 2 goals by deploying a functional prototype of crop yield prediction system based on linear regression. We deployed a project using linear regression which predicting the outcome of crop yield. The integration of real-time weather data with and an interactive interface provides a practical and accessible solution for farmers. It helps the farmers with our UI, and UX is very user-friendly, so that farmers will feel easy to use it. The system achieved an accuracy of 80%, making sufficient progress towards the final deployment phase. In the final deployment phase, our accuracy is 80% here. Overall project completion stands at approximately 75%. As of now, we have completed 75% of our project. Thank you guys.